All right, if you're just joining us, we are working through the Unit 5 unit review, and we are now on to question number 5. Now, number 5 here says, using Avogadro's number, do the following, and make sure you show your work and use the labels. Remember, Avogadro's number, 6.02 times 10 to the 23. Now, you want to make sure that you are skilled and proficient in using your calculator, your scientific calculator, to be able to type that in correctly onto your calculator. So let's go ahead and get started. It says, how many atoms are there in 0.0015 moles of zinc? So we'll start with our given, 0.0015 moles of zinc. And then we're going to take our given and we'll put that over 1. Now, the nice thing is we do not need to use the molar mass. We don't need to go to our periodic table. We just know that 1 mole of anything is 6.02 times 10 to the 23 of them. In this case, we're talking about atoms of zinc. And then from here, we simply multiply across the top. So 0.0015, oh, helps to turn the calculator on. Why is the calculator not coming on? Well, I did the math here earlier, so let me go ahead and write that out. This does end up being 9.03 times 10 to the 20 atoms. 9.03 times 10 to the 20 atoms. Letter B says, if you had 2.5 moles of oxygen gas, what's the mass of the gas that would be in this sample? Remember, oxygen gas, when oxygen is by itself, it is diatomic. So we want to have that as O2. So 2.5 moles of O2 is how many, what is the mass of it? So we will need to use our molar mass. So 2.5 moles, so 1 mole of O2 is going to be 32 grams of O2. And so that gives us about 80.0 grams of O2, 80.0 grams of oxygen. Now let's go ahead and turn over to our next page for letter C. And letter C here, let me get that lined up. There we go. Letter C, we start off with 4.07 grams of NaI, sodium iodine, and it contains how many grams of, how many atoms of sodium? So a couple of steps that we need to do here. First of all, let's start with our given. 4.07 grams of sodium iodine over 1. From there, we want to take it into the mole. And to do that, we want to go ahead and use our molar mass. So we'll have 1 mole of sodium iodine is 149.9 grams. And then from there, we want to go into how many atoms are in there. Atoms of sodium. So 6.02 times 10 to the 23 molecules, or technically these are referred to as formula units, but we'll call them molecules or formula units is another way of describing those when they're ionic. For every 1 mole, and for every formula unit or for every molecule, there's 1 atom of sodium. 1 atom of sodium, and every 1 formula unit of sodium iodine. Kind of running out of room here a little bit. So going through and do that math again, multiplying across the top, multiplying across the bottom, should give us something about 1.63 times 10 to the 22 atoms of sodium. Letter D says, how many atoms of chlorine gas? Now remember, chlorine gas is one of those that are diatomic when by itself, is in iron chloride. So iron chloride, it would be FeCl3. That's kind of the formula there for iron chloride. So a couple of things we need to do. First of all, is always start with your given over 1. In this case, our given is 16.5 grams of iron chloride, and that will go over 1. From there, we want to bring in our molar mass of iron chloride. So again, looking up on the periodic table, the molar mass of 1 iron and 3 chlorines is 162.3 grams for every 1 mole. And now we want to get to the formula units of iron chloride, molecules or formula units. 6.02 times 10 to the 23 formula units in every 1 mole. And then finally, the question is, how many atoms of chlorine are there? Well, we see that for each 1 formula unit, we actually have 3 chlorines. So for each formula unit, we have 3 chlorines. So we have 3 atoms of chlorine for every 1 formula unit of iron chloride. And that would be our last step. So from here we do the math. We end up with 1.84 times 10 to the 23 atoms of chlorine. And then finally, letter E says, what is the mass of 100 million atoms of gold? Could you mass this on a scale? Okay, so if you could find this on a scale, could you actually find this mass? Well, let's see. 100 million atoms of gold. Well, 100 million. I'm actually going to turn this into 1.0 times 10 to the 8 because 100 million is a lot of zeros to type in. Atoms of Au, that's gold on the periodic table. Let's see. Well, first of all, we need to know how many moles that is. So we're going to divide that by Avogadro's number, 6.02 times 10 to the 23. Atoms are 1 mole of Au. And then from there, we need to know the mass of that. And we'll multiply that by the molar mass of gold, which is 197.0 grams of Au for 1 mole. In doing that math, we end up with 3.27 times 10 to the negative 14 grams of gold. So the question is, could you mass this on a scale? Well, the answer is no. It's simply too small to be detected by a scale. Simply too small. Guys, I hope if you have any questions, please let me know, and I hope that helps.